Okay, let's give this a go with something a little mathy, but not too bad. So this is still going to be rather conceptual. I want to know ammonium cyanide, if I put that in solution, what am I going to get? Will the solution be more acidic, more neutral? Come on. There we go. More acidic, more neutral, can't tell, or basic. Okay, so how are we going to figure this out? Let's write it out. I can have this, if I put this in water, sorry, H2O. What I'm going to get, that would give me NH4 plus CN minus. So this is just like one of the examples that we did at the very beginning where we were trying to decide which reaction is more likely to go. So what are my options? I have NH4 plus with water. And again, the ammonium can only give up a hydrogen, so I'll end up with ammonia plus H3O plus. And then what is my other option is my cyanide. So Cn minus plus H2O. Going to, well, the only thing cyanide can do is accept a hydrogen, so I'll end up with HCN plus. Now I've taken a hydrogen away, so OH minus. So I need to know which one of these is going to be dominant, because the dominant thing is the one that's going to either increase or decrease the pH, make it more basic or more acidic. We're going to do the same thing that we did like 2 little mini lectures ago, and we're going to use our Ka values and our to determine the strength. I shouldn't say we didn't use our Ka values. We used the strength of the acids and base tables, but now we can use our Ka values. So just like I tried to explain to you before, I don't have you manipulating Kas because it entertains me. I have you manipulating Kas because this kind of table is the one that you would find in a book. And then what I left off with at the last lecture was that Ka, don't forget, is going to be equal to K water, sorry. K water is going to equal to Kb times Ka. Ka times Kb, same thing. So if I have Ka, then all I need to do is go my Kw divided by my Kb. Yeah, my brain just stopped. Kb, there we go. So what we're going to do then is look here and see if one of those has a higher Ka or Kb, then that means it is going to produce more product. If it's going to produce more product, then that is going to be the dominant reaction. Give me 2 seconds here. Rico! All right, so NH4, where's my ammonium? There it is. I have NH4, has a Ka. Where'd it go? 5.6 times 10 to the negative 10 is its Ka. My Cn minus, I want its Ka, but that's not going to do me any good. I need to know what its Kb is to know if it's going to produce a lot of the base. So where's my Cn minus is right here. So there's the conjugate base, and here is my Ka. So the Ka is 6.17 times 10 to the negative 10. Now I haven't told you anything about temperature. So these tables are all at 25 degrees C. If you have something like this and you haven't been told that the temperature is different, then we can assume that the Kw of 10 to the negative 14 is going to be the thing we use. So I'm going to do that and see. I want my Kb. Why did I solve for Ka? That's silly. So Kb is going to be Kw divided by Ka. So 10 to the negative 14 divided by my Ka, 6.17 times 10 to the negative 10. Let's see, do I need to put this into my calculator to see? Let's just kind of do our quick check. I'm going to have 1 over 6.17. So this is going to be a smaller number than 1/2 times 10 to the negative 14 times 10 to the 10. That's a 10. That means I'm going to have 1 over 6.15 times 10 to the negative 4. This thing here is just going to make this 10 to the negative 5. So smaller than 1/2 times 10 to the negative 5. That is already larger than ammonium's. So what that tells me, without doing any button pushing at all, because I wasn't asked to solve for anything, is that this CN is going, its KB is higher than NH4's Ka. So it's going to be the dominant reaction, which means I'm going to have something that is more basic. All right, next one we'll do some math.